This is lesson 1.4a. We're going to be looking at equations and expressions with two variables in contextual situations. Our objectives are to be able to write these equations and expressions, and then we're going to use those to solve some problems. I want to direct your attention to y equals mx plus b. This is a linear equation, but it's also an equation with two variables. Our variables are x and y. Okay, there's also an m and a b in here, and if you know from graphing, you knew that m was your slope, or your rate of change, and you knew that b was your y-intercept, or your starting point on the y-axis. But I want you guys to think of this now contextually. In this situation, or these situations, these scenarios, b will always represent your starting amount, or some fixed amount. Like for example, in the ice cream van problem, you had to pay $6 to rent the van. That is a fixed amount. That is not per mile or anything like that. That is a one-time fee you have to pay to rent the van. M, on the other hand, represents a rate of change per some time period or per ice cream cone. So you had to pay 50 cents for each ice cream cone that you sold. That's what it cost you if you were to go to Safeway or King Super and buy those ice cream cones. It was 50 cents per ice cream cone. So I want you to think of M as an amount that changes per something else. In our first example, we have Jocelyn, and she makes X dollars per week at the grocery store. So right there you see a per. We know right away that X is going to be paired with some number. And she makes N dollars per hour babysitting. Again, that's another per. So both those are going to be multiplied by something. We want to write an expression that describes her earnings if she babysat for 25 hours and worked at the grocery store for 15 hours. Couple things to think about. We know that the variable x represents the dollar amount that she will make at the grocery store, and n represents the dollar amount that she will make babysitting. So we don't know how much she makes per hour or per week, but we do know that we have some variables to represent that. So let's write this as an expression. We have 15 times x, so x represents the dollar amount she makes at the grocery store. We know that she works 15 hours at the grocery store, so 15 times however much she makes per hour. And we're going to add that to 25n, and n represents the dollar amount that she will make babysitting. So 25 hours that she works babysitting times however much she makes per hour will give us how much she makes. Let's look at another example. This has to do with travel, and you guys often see this. Amelia drives at an average of 65 miles per hour. When you're driving down the road, you see the speed limit, and it will tell you 45 miles per hour, or a school zone, 20 miles per hour. Okay, there's a per right there, so that 65 is going to go next to some other variable. We want to write and solve an equation to find the time it will take her to drive 97.5 miles. So some things to think about. The variable in this problem will be the number of hours she will drive. We don't know how many hours it will take her to drive. That is what this question right here is asking. Find the time it will take her to drive. The total distance is equal to 65 miles times the number of hours driven. So this middle part right here is really going to be what our equation amounts to. Total distance is equal to 65 times h, right? Hours driven. Now, if you look down here, it's saying let d be the total distance and h be the number of hours driven. Many times when you're graphing, you see these as x and y, but we can use other variables to represent x and y that make more sense in our problem. D just makes sense to think about that as distance rather than y, and h, it makes sense to have it be hours rather than x. So you can change the variables if you want. So here's our equation. Our total distance is equal to 65 miles per hour, okay? And we are trying to find the hours. We know the total distance. The total distance was given to us as 97.5 miles. If we plug that in, we have an equation, and it will be very simple to solve. We need to solve for h, our hours. In order to do that, we need to undo this multiplication. We need to get the 65 away from the h. So we just divide both sides by 65. Use your calculator, and you get 1.5 hours. So it will take her 1.5 hours to drive 97.5 miles. When you are doing these problems, think about it in your mind. Make sure that it makes sense. Okay, if she drives 65 miles per hour, that means in 1 hour she will have gone 65 miles. If we're trying to figure out how long it will take her to drive 97.5 miles, we know that it's probably going to be somewhere between 1 and 2 hours, logically. So our answer should represent that, and it does. In our next example, Mr. Hernandez pays $10 each month for movies that are delivered by mail, and he can also rent movies in the store for $1.50 per title. So there's that per again. So it costs him $1.50 per movie. We want to write and solve an equation to find the total amount that he spends this month. So we're just looking at this month if he rents 3 movies from the store. Some things to think about. Over here, the cost of the movie plan is a flat fixed rate, right? It doesn't change. No matter what, he pays that $10 for this month. The variable is the number of movies he rents from the store. We don't know how many movies he rents from the store. In this example, we're going to assume he rents 3, but that's going to change every month. The total cost is the price of the plan, which is that $10, plus $1.50 times the number of movies rented from the store. So that will be our equation. Again, we're going to choose other variables other than x and y. We're going to let c be the total cost and m be the number of movies. Just makes sense. So, writing our equation, this is our y equals mx plus b equation. Our total cost is going to be equal to $1.50 per movie. Those are multiplied, plus a one-time fee of $10 for the month. This question says he is going to rent 3 movies. So we put in 3 in place of m, which stands for our number of movies. We multiply 3 times $1.50, get $4.50, add the 10, and we find out that Mr. Hernandez will spend $14.50 on movie rentals in 1 month. All right, let's do a final problem here. Let's look at perimeter. Perimeter is the distance around any kind of shape. So in this situation, the perimeter of a regular octagon. So it's important that you understand what regular and octagon is. Well, octagon is an 8-sided figure, and regular means that all the sides are the same and all the angles are the same. So we are given a perimeter of 128 inches, and we want to create an equation that represents this perimeter, and then we can find the length of each side. Again, a couple things to think about. The variable in this is going to be the length of each side. We don't know what that is. That's our unknown. The total perimeter, which we are given, 128 inches, is going to be equal to the length of each side times 8. If we think about this problem, perimeter is each side added up. In this case, all the sides are the same, so we can just take one of the sides and multiply that by 8. Some of you guys, when you were doing the tile problem and you were analyzing the border and how many tiles it would take to surround this lunchroom, you guys did the same type of thing. You counted up and you multiplied. And that's what we're doing here. So in this case, we're going to let P represent our total perimeter. That would be in place of Y, and we're going to let S be the length of each side. And that would be in place of our X. So we come up with an equation. Perimeter is equal to 8 for 8 sides times whatever the length of each side is. And like we said, that's our variable up here. We don't know what that is. Okay, our perimeter is given. We said over here it's 128 inches. So we can substitute that perimeter in, and we'll be left with just an S, which is what we're trying to solve for, the length of each side. Again, we need to undo this multiplication. So to undo the multiplication, we divide both sides by 8. Using our calculator, we get a side length of 16 inches. Okay? So it is very beneficial to take these contextual word problems and put them into some sort of an equation or an expression, and then we can use that to solve to find what we're looking for.